I have some very special guests with me. We have Matthijs Hollemans, who is, as some of you may know, authored the recent book that we came out with earlier last week. So he's here to tell us a little bit more about the book. Ooh, he's got a copy with him as well. So we're going to talk a little bit about that. By the way, a little plug. We're going to be doing a couple little plugs today. If you're interested in the book, we have it, the link to it in the video description. So thank you very much for supporting, for all the people who have bought it so far. And yeah, please support if you haven't got it. It's a great resource if you're looking to get into audio software development, looking to take your next steps. Maybe you've watched some of my video tutorials and are looking to get more in depth with it. And that's a great resource for it. And so he's going to talk about his book, Creating Synthesizer Plugins with C++ and JUCE. Over to you, Matthijs.
Thank you very much. As you said, I wrote a book. It's called, I don't know, does it show up in reverse? Probably does. It's called Creating Synthesizer Plugins with C++ and JUCE. This here is the paperback version. We also have ebook versions, PDF, EPUB. But the paperback came out really nice, so I have to thank Josh for that because he put that together, and I'm really proud of it. It's really cool book. In this talk, I just want to talk a little bit about the book, what it is, who the book is for. I want to give you a little audio demo of the plugin that we built in the book, and then I just want to go through the book in a bit more detail, just to give you a sense of what's in the book and make you decide if the book is something that you would be interested in. So I will share my screen now, which is a bit easier than flipping through the book, the physical book. So here I have the PDF version of the book. So I just want to scroll through it a little bit just to make sure, give you a sense of what's in the book. I'm sure if you are really fast, you could probably read along, but I'll highlight some interesting parts of the book later. But the main thing I want to show is that there's a lot of pictures in the book. There's also a lot of source code in the book, and not a lot of math. I think that's one of the benefits of this book. So I want to talk a little bit about what the book is about and who the book is for. So the title kind of gives it away. It's about creating synthesizer plugins with C++ and JUCE. But it's really important to understand it's like a tutorial style book, which means we go step by step, starting from a blank project and then filling in all the pieces you need. And at the end, we end up with a complete synthesizer plugin. And I'll be happy to show you that finished plugin in a little bit. So you can see, what we build towards in the book. But it's the book is written for beginners. So if you've never done any audio programming before, or if you've never done anything with synths before, that's really who the book is for. It's really written in a hands-on style. So you're supposed to read it from beginning to end and follow along with all the explanations and type in all the source code. And that's how we build up your knowledge of how to make synths. It's really very practical, hands-on tutorial style book. It's not a reference book so much. The synthesizer that we will build is a virtual analog synth. And you have to think about synths that were, synths you could buy in the 60s and 70s and 80s. That style of synthesizer is what we're building. I'll explain a little bit more exactly what that means for the synthesizer. But it's not a book about all possible ways to build synthesizers. There's loads of ways you can build synths, and we're just focusing on one particular way. But it's also very a fundamental knowledge of how to build synths. So once you understand how to build this virtual analog synth, you're in a good place to go on to like an FM synthesizer or a wavetable synthesizer or physical modeling synth. But you need to know these basics anyway that we will learn in this book. So I think it's a good starting point for people who want to learn about building synths, even if you're not really interested in building a virtual analog synth. The title also says C++, which means that we use the programming language C++. It's not necessarily the best language for beginners, but you do need to know. You need to know at least a little bit about programming in order to get the most out of this book. It's okay if you're not super familiar with C++, because we're not going to go into all the possible features of C++. We only use like the bare minimum that we need to get by. But if you've never programmed before, then it might be a bit much because we don't really go into all the details about the language. Now, there's lots, like I said, there's lots of pictures. For example, like we're gonna, let me scroll quickly through some examples. So, for example, whenever we need to do something in the IDE or with other tools, there are pictures in the book that explain what things to click on and so on. So it still takes you by the hand. It still explains everything you need to know. So it's fine if you're not super familiar with some of these tools. Everything's explained, but I can't really go into the teaching you how to program from scratch. So it's nice if you bring some programming knowledge if you already have some programming knowledge. And if you don't, the book does has links to places where you can learn about C++ and so on. But to make the most out of this book, you should know how to program a little bit already. The last thing on the cover is JUCE. Now, JUCE is an audio programming framework, and we use it mostly for the plumbing. What I mean by this is we're going to make plugins, and there's lots of different plugin formats, and we don't want to deal with all that stuff. We just want to deal with how do you write a synth. So we use JUCE to take care of all the annoying bits for us so that we can focus on the audio programming. JUCE also has this library of DSP functionality, but we're not using any of that. We're writing all of the DSP code, all of the audio programming code from scratch, because that gives you the best knowledge of how to do audio programming. JUCE is great, the DSP library is great, but in order to really learn how everything works, we're going to write everything from scratch. So even if you don't really want to use JUCE or can't use JUCE, maybe you want to use some other framework like iPlug or something, the book still is useful to you, because most of the interesting bits, the interesting code is all independent of the framework. But the reason that we use JUCE, the reason we use C++ is because these are the standards of audio development, right? So if you want to get a job as an audio developer, you will probably end up using C++ and JUCE. By the end of this book, you should have a pretty good sense of what digital audio is, how to synthesize sounds, how plugins work. It's really supposed to be an introduction to the world of plugin development by building a synth from scratch. And with that, I would like to, oh, I'm actually forgetting something. We do have the source code available. It's on GitHub. If you're interested in checking out the plugin, but you don't really haven't decided if you want to check out the book, if you want to get the book or not, you can go on GitHub. We have all the source code from the book is there. You can find it by chapter. So if I look at like chapter 2, there's a source code. It's really very simple. We haven't done much yet, but a few chapters later, like chapter 6, it already starts to be, we already have a whole bunch of source code. And by the time the project is finished, we have like a fairly decent amount of code that we've written together. You can also check out some audio demos on the GitHub page. So I've got some MP3 files that were made with this synth, no other effects were used. So that's also something you might want to check out. But I will actually give you a live demo of the synth in action right now. So that might be more interesting than listening to some of these demos. So I'll hide some of these things and I'll bring up the synth. Okay, so what you see here is a simple audio host program. It's called Audio Plugin Host. It comes with JUCE, and you can use this to test out your synths. It's really useful for things like debugging synthesizers or any plugins. the synth that we will build, it will work in any host. So I've tested it in Logic and Reaper, for example. Because we're using JUCE, we make a VST3 version and an audio units version. And if you wanted to, you could even make a version for Pro Tools. So it's really a synth, just like any commercial synth you could buy. You could use it in any host, any DAW. But for this demo, I'm just going to use Audio Plugin Host. So I have a MIDI keyboard here to my side, which you can't see. And if I play the notes on this MIDI keyboard, it goes into this MIDI input block, which is connected to the synthesizer, which is called JX11. And then the synth sends its output to the audio output. And that's really what a synth is. It's something that takes MIDI information, processes it, and then generates sound and sends it to the outputs. The reason there are like multiple outputs here is just to get it to work with Zoom, which is what we're using right now. And if I press some keys, you should hear some sound. So we had some trouble getting this to work earlier, so I hope it still works. I don't know if any of the other people could give me a wave if the sound worked.
Yep, all good.
Oh, all right, excellent. So I want to talk a little bit about this synth, so I can open it up. This is the user interface, which is not very pretty. This is what you get in JUCE when you don't provide an actual user interface. It's automatically generated. On the left here are all the parameter names. And for each parameter, there's like a slider control that you can use to set the parameter. And this synthesizer is a so-called virtual analog synth or a subtractive synth, which means it has an oscillator, which creates a sound. The sound then goes through a filter, which is used to modify the sound. And then there's a bunch of other things along the way as well, but that's really the basic idea. We start with a sawtooth wave, which what you just heard, which is what this sounds like. And then that goes through a filter, and then we can use that to shape the sound to make it into something more interesting. Now, this particular synth is not something that I wrote myself. I found this on the internet. It comes from a collection of source code that was donated by its author, Paul Kellett. This is the MDA suite of plugins. This was a fairly popular suite of plugins, free plugins around in the early 2000s. And Paul, he donated his stuff as open source. And I thought that's really great because the MDA plugin suite is really nice. It has a lot of stuff in there. And you can really learn a lot from audio programming by studying those plugins, which is what I was doing. And I found that the JX10 synth was really nice because it's not too big and it's not too small. If you want to explain to someone how to build a synth, you don't want to have some huge project with loads of features, because that makes a book that's 1,000 pages and nobody wants to read a huge book like that. But if it's too simple, then it's also not very interesting. But this JX10 synth was really like the perfect mix of features. So I thought that's a great idea. I'm going to figure out how it works, and then I'm going to turn that into a book. So that's what I did. I took that source code, I modernized it. The original code had some bugs, had some issues with it. There were some more modern ways to approach things. So that's what I did, and that's what the synthesizer turned into, JX11. So I'm really thankful to Paul for open sourcing his synthesizer, because it gave me the idea to write a book on how to make synthesizers. And again, I think his synthesizer design is like the perfect set of features that you want to put into a book for beginners. So I think maybe I should just play with the synth a little to give you an idea of what it sounds and what it's capable of. But like I said, the features it has are very similar to analog hardware synths from the 70s and 80s, which means there's two oscillators that work together to make sound, and then the filter filters that sound, and then there's a whole bunch of other features that we can use to modulate the sound to make it more interesting. So what you hear now is just a boring sawtooth wave. And I'm playing a chord, so it's a polyphonic synth, meaning that it can play multiple notes at the same time. It also has a special mono mode, which is also an interesting way to play. It's mostly interesting for playing like lead lead synth lines and so on, or bass lines. But right now we're using the poly mode, so I'm just playing a 3-note chord here, but it's just one single sawtooth, so it's not a very interesting sound. But I can add in the second oscillator, and now you'll hear that the whole thing sounds a bit lower and richer. And I can tune the second oscillator to be something else. So now we have, again, the two oscillators playing together, but they are at a different relationship to each other. I can just put it up 2 octaves higher. So that's the basic sound generating feature of the synth. There's also a noise oscillator, which is at the bottom. I can add that here as well. And now we'll add some noise to the sound, which if you add a lot of noise, it doesn't sound very interesting, but it can be used for special effects. So once we have the sounds coming out of these oscillators, they can go through a filter. And if I play the same chord again, I can change the filter cutoff point, and you'll hear the sound change. And that's really the basis of a subtractive synthesizer. And all the other features are there to help make this a little more interesting. So for example, I was moving the filter frequency back and forth, but you can also do this automatically using the filter LFO, for example. So an LFO is a low frequency oscillator. It's a typical thing used to modulate sounds. So if I move this slider up, you can hear that it does a sort of like a wah-wah effect. And I can change the speed of that with the LFO rate. So that's one way to get a more interesting sound. The other way is to use the filter envelope. An envelope is a way to describe it, how the sound changes over time. And we use a typical ADSR analog envelope in the synth. And there's like 2 envelopes. There's one just for the amplitude of the sound, which means if I set the attack, for example, then you'll hear the sound fade in. Well, maybe not in this example. And this is a typical way to shape sounds with the envelope, but we can also apply the envelope to the filter. And in fact, it was already active. And if I turn the filter envelope up a little bit, maybe I should just play a single note. It's a little subtle, but you can hear that when the note starts, you can hear the filter value change a little bit. And if I change the filter, let's change the filter decay. Change the filter attack. Maybe change the resonance a bit. You can hear some interesting filter movement at the start of the note, and you can do the same thing at the end of the note, which I'll demonstrate in a little bit. And then, in addition to this, we have. I already showed that there's an LFO for the filter. That same LFO can be used to add vibrato to the sound. And if you set up the oscillators in a special way, then it can also do something called pulse width modulation, where the 2 oscillators combine to make a square wave, and then it changes the width of the pulse. Now, these are all the basic parameters that are in the synth, and together you can use them to make interesting sounds. And so if I open the list of factory presets, then, I mean, I'm not a great sound designer, but some people are, and various people have contributed presets to the original JX10 synth. So I added those same presets into this synth. And I just want to show you a few of these just so you can get a sense of all the different sounds that the synthesizer can make. Because it looks like a fairly simple synth, just two oscillators and a filter and some envelopes, but that's really all you need to make very interesting sounds already. So for this particular preset, you can hear that when you start playing a note, the filter sort of comes in, and then when I let the note go, the filter also, as the sound fades out, also the filter changes, which is quite an interesting effect. But for a totally different effect, we can try some of the other presets. We also have some lead sounds. I'm not playing the most interesting tunes, but I guess that's, want to avoid copyright infringement. There's also some bass sounds, and this one's interesting because it shows another feature of the synth, which is a glide. So if I play one note and then I play another note, you can hear that it glides between these notes. And if I set the glide value a bit higher, then it's a lot easier to hear. And, there's like a whole bunch of other presets. I'm not exactly sure how many there are, like 40 or something. Very interesting sounds. Quite a wide variety of sounds. So even with these really basic features, like these oscillators and just a simple filter, you can already do quite a lot. So I think that's why I thought it was a very interesting synth, because it shows that you only need to implement like a number of simple features like oscillators and filters and stuff, and then you put them all together and you get very interesting effects. Like this echo pad, for example, this preset. It kind of sounds like it has a delay in it already, but there's no delay in the synth. It's just somebody was very clever with how they used the feature of the synth to make that sound. I think that's what I wanted to show about the actual synth that we're building. So I will close this, and then I'll pull up the ebook again. And now I just want to go through the table of contents a little bit, just to give you a little bit more information about what's in the book and in what order and how is stuff explained. So I see this book really as a story where we start from not knowing anything, basically, to adding all the pieces of the synth, slowly building out the synth until it's like the complete thing. It's not like we start from nothing and then only something interesting happens by the last chapter. In every chapter, we add new features and make the synth more interesting. So right away, you already start building the synth, and then you start adding the new function. You keep adding functionality to the synth. So you keep building it, you keep growing it. And if you feel like halfway through the book, you've already learned enough and you're ready to go make your own synth, that's great. Let's just go quickly through the table of contents. So there are 14 chapters in total, but the first 12 chapters are all about audio, the audio processing part of the synth. And then there's a chapter about the user interface, which you saw that the user interface that I just demonstrated wasn't very pretty, but we actually go into building a real user interface for this synth as well. And we'll talk about all the interesting problems that are involved in making user interfaces, but also making your own styles making your own look and feels, as we call them in JUCE, and tricky things like making the audio thread talk to the UI thread and so on. But that's, kind of an advanced topic, which is why it's at the end of the book. The book begins by talking about what a synth really is. And if I go to this chapter, you can see that it talks about these things that I quickly went through just now. We have a sawtooth oscillator, and then we have an envelope to change the sound, and then we filter the sound, and then we add modulations and so on. And we end up building the thing that's shown here in this schematic. This is how all the different pieces fit together. You see all the parameters here and all the building blocks that make up the synth. And we will write all these things from scratch. And I'll explain how each of these things works and how you might even want to approach them differently, for example. So this is essentially an overview of everything that you learn from this book. Let's quickly go back to the table of contents. So as I said, we use JUCE. If you've never used JUCE before, that's fine. It's explained completely from the beginning, how to install it, how to set up new projects. JUCE is a little strange in how you create projects. If you've done C++ before, then using JUCE might be a little strange, but it's all explained here. Also, if you don't want to use JUCE, this chapter explains how you can still use the book. Then we'll talk about MIDI and digital audio. Now, MIDI is the input to the synthesizer, and it's not necessarily difficult to understand, but it is a little tricky to do right. So that's why there's like 2 chapters dedicated to it. And if you want to make synths, then having a good grasp on MIDI is really a good idea, because everything that goes into your synth is MIDI. So you definitely want to understand how to handle MIDI and how the MIDI protocol works. But also the output of the synth is digital audio. So it's also useful to understand how digital audio works. And so the book explains everything about sample rates and sampling and how all that stuff fits together. And then we'll build the synth. So we start with oscillators. Oscillators are the things that create the initial sound that comes out of the synth. And the simplest oscillator is a sine wave oscillator. So we'll spend quite a bit of time making sure you know how to build sine wave oscillators. Now, the synth itself doesn't really use a sine wave, but it uses a sawtooth wave. But still, that builds on those ideas. And for the LFO that we use for modulation, we do end up using a sine wave. So it's this is a good set of chapters to really work through to understand how to make sound out of nothing, basically. And for the sawtooth, we have another problem, and that is oscillators and basically anything we do in digital audio always has the possibility of creating aliases, which are frequencies that we don't really want, nasty frequencies that create buzzing and so on. And to avoid this, the book uses a technique called blit, which is an older technique. But I still thought it was very interesting to explain it because it allows me to talk about impulses and impulse trains. And these are like fundamental concepts in audio programming. And I thought it's important for a book like this to not just give you a bunch of source code that does certain things, but also to help you understand what are the basic ideas in DSP and audio programming. And, an impulse, that's like the most fundamental signal that we deal with. And the sine wave is the most fundamental kind of waveform that we deal with. So the book does spend some time on those ideas and explains, why would you want to understand these things? And then we just keep on adding things to the synth. We do the envelope, which is also, one of the basic fundamental synthesizer building blocks. We will talk about polyphony and voice management, because if you're playing a single note, then you just have one oscillator or 2 oscillators and a filter. But if you play 5 notes, then you need 5 times that many oscillators and filters. And how do you manage this in a way that actually makes sense? And I found that getting voice management right in the synth can actually be very complicated. So that's why we dedicate a whole chapter to it. And then we talk about modulation, such as the LFO. We can also do stuff with the modulation wheel on the MIDI controller, or the pitch bend wheel, or any other sliders and stuff. I didn't really demonstrate these features, but the synth does have quite a few modulation options. And that's what that chapter is about. And then we conclude with the filter chapter, which is also, the filter is what makes a subtractive synth like this. So we do spend some time on getting the filter right, and also how to modulate the filter. And then finally, I want to quickly go through the user interface chapter, because I didn't really show the user interface of the synth, because we do spend most of the time talking about how to actually get the audio processing done. But it wouldn't really be a complete book if I skipped the user interface, because there are things you need to know about how to interface or how to talk between the audio thread that does all the audio processing and the message thread, or the UI thread that shows the UI on the screen. And so we go into that in the book. It shows you the responsibilities of the different objects in your synthesizer code, and how to make sure you can safely communicate between them. And then we talk a little bit about the user interface. Let's see if I can, there's a thing in the way. See if I can zoom in a little bit. So we do have in this chapter build a custom user interface, and JUCE has these rotary knobs or dials that you can to build your user interface, but they look like this, which is not very interesting. So the book also shows how to customize this and to get a user interface that looks more like, where is my picture? That looks more like this. So it's a small change, but you'll have everything in this chapter in order to finalize like a complete custom UI for this synth, or for any other plugin for that matter, because it doesn't, a lot of the things you learn in this book, they apply just as much to building effects plugins as to synths, especially when it comes to user interface. And then we do some other stuff like MIDI learn, where you can assign a knob or a slider on your MIDI controller to features in the synth, and lots of other stuff like this. I mean, the book is packed full with information and handy tips and other stuff. You could probably read it 4 times and still discover new things. There's also some math. So here's a little bit of math, but I try to keep the math to a minimum because, I have DSP books where page 1, you open it up and they already throw equations at you. I don't really find that very interesting most of the time, but I do like, I do like to jump into the code. But it does make sense that we use some math in order to understand what's actually happening. Because in the end, DSP programming and audio programming, you do need to use some math. You can't really avoid it. So the book doesn't really pretend that there's no math, but it does keep the math to a minimum. Just because I don't think it's super useful to, drown people in math when they're just getting started. So I'm pretty proud of this book. I think it's a good introduction to learning how to write your first synthesizer plugin. And I think that's pretty much what I wanted to share about this book for now. So if there's any questions, I'd be happy to answer them.
Fantastic. Thank you so much, Matthijs. I'm going to bring you back to our main. Actually, I'll keep that up for a little bit, but great. So we have a couple questions, and for anybody who's out there listening and curious about, wants to know more, please feel free to ask questions. In the meantime, I've got a couple here. So Tugrol asks if you implemented polyphony from scratch, or did you use the JUCE library to implement polyphony?
Everything related to the synthesizer is implemented from scratch. So JUCE does have a synthesizer class, that you can use to build synthesizers, but we're not using it at all. And the book does. So the book does, in some places, refer to these things. So it says, in the chapter about polyphony, it says you could also use the JUCE thing, but we're not using it. There's also the chapter about the filter. We also use our own filter, but it does give you some instructions if you want to use one of the JUCE filters, because JUCE has an interesting, like a ladder filter that does sound different from the filter that we're using. And I thought it's useful if you see how to use some of the JUCE DSP code in your plugin anyway. So that's just an example of how to use the JUCE stuff. But pretty much everything else is just from scratch. And that's not because the JUCE stuff is bad or anything. I just wanted to show you how to build it from scratch. Because if you look into the JUCE source code, like if you read this book and then you go look at the JUCE source code, you'll see like, oh, they do a similar way or they do slightly different, but you'll be able to understand what JUCE does then as well.
That's really awesome. Yeah. So if you've been following along with the audio programmer and some of the synth tutorials that I've made in the past, you'll see that I used JUCE's built-in synthesizer classes. So you have synthesizer voice, and there's another one, I can't remember it.
Sound, I think.
Yeah, synthesizer sound. That's it. So if you want to know how synthesizers actually work and how to build those classes from scratch and get a little bit more serious about audio programming, this is the book for you. So next question is from Bruno Santos, who asks, what would you say is the best way to follow along with the book? Is there a recommended way that you'd say to follow along?
Well, like I said, it's a story, right? So you start reading it, and then it says, now we're going to install JUCE. Now we're going to do this. Now we're going to do that. Now we're going to type in this source code. And this is what that source code does. And then you type in the next bit of source code and it explains what that does and how it fits together. So it's really, maybe I can just show you on my screen here since I'm still sharing it. Let's say, so here we're talking about the sawtooth oscillator. And it shows you, it explains to you what we're going to do, what the sawtooth is, and then it says change the code in oscillator.h to the following, and then you do that, and then you run the plugin, and then you'll see the following thing in your oscilloscope, and then I explain why that works and what the problem is with this, and how we can do it better, and then you type in a new bit of source code, and then you run the program again, you play with it, you look at the oscilloscope, you look at the frequency analyzer, and that's how you just follow along. And, hopefully every step of the way, if you have questions, they are answered in the next paragraph in the book. I try to write it as a story. If I would explain how to do this to someone like one-on-one, that's probably how you would do it. You say, now let's try this. And then what are the problems with it? And then let's try the next thing and so on.
Fantastic. Luke O'Dwyer asks, hey, the book looks great. Can I ask how in-depth a programming background would one need to utilize the book? How advanced would you need to know programming concepts as a prerequisite? So in theory, you don't need to know any programming because you copy paste code from the book. But it's nice to know what's going on when you do that. Like this is what I just showed here. Change the code in this file to the following. It's nice if you understand what a class is and what these things here are and what the method is and so on. I mean, that's like super basic, but if you have no idea what this code says, then it's also kind of pointless to be writing it because you have no idea what you're doing. And you might as well just, go to the GitHub, download the full project and run that rather than just copy pasting if you don't know what's going on. However, if you only have like basic programming skills, it's still fine because it's not going to be much more complicated than the source code I've shown here. Most of the source code
that's used is very straightforward. There's no fancy stuff. Like C++ code can be as complicated as you want to be, but I've tried to keep it as simple as I could, without any fancy features or things that require, you don't have to be like a 10-year programming veteran to make sense of it or anything. But one thing I want to say is that if you don't have a lot of programming experience and you make a mistake, you can get really strange error messages that don't make any sense to you. So for example, here, this source code on the screen, it ends in a semicolon. If you forget that semicolon, for example, or if you forget one of these braces, you can get really strange errors and you have no idea how to fix them because, the compiler messages won't make any sense to you. So that's the problem. If you don't have a lot of experience, then if you make a mistake, it can be very hard to figure out, how to fix it. However, we do have Discord, and if you buy the book, there's a private Discord channel that you can join, and I'm there most of the time. So if you run into any of these strange errors and you have no idea how to fix it or where it comes from, just ping me, ask the question there, and I can probably help you on the way. So I don't want to scare you off if you don't have any programming experience and you really want to learn how to make synths. I mean, just give it a try and ask for help if you get stuck.
Yeah. And another thing is there are some great resources if you're looking to learn C++ and the basic concepts. There's a channel called The Cherno, which is fantastic for learning C++ concepts, given from a game developer who used to work at Electronic Arts. I also have some basic C++ tutorials where I actually taught my son, who was 16 or 17 at the time, basic C++ fundamentals. So there are a couple good resources out there if you're looking to learn some of those fundamentals while you're working alongside the book. So we have another question from Carmelo, who says, would you say that the way that you implemented the core algorithms is quote unquote better than the ones used by the JUCE library? Or did you decide to implement them from scratch just for educational reasons?
Both. And I don't want to diss the JUCE library because a lot of the DSP code they have is pretty good. But like this JUCE synthesizer class, for example, I wouldn't call that great code, right? It's something you can use to quickly throw something together. But if you want to build a synthesizer that's more than I think they made it to make it easy to create samplers or rumplers, where you press a key and it plays a sample. But for more advanced synthesizers, I don't think that JUCE synthesizer class is really sufficient. And usually when people ask on the Discord, we say, just write it yourself. It's a lot easier than trying to hack that synthesizer class into doing what you want. But everything else, the main reason is educational and to make the book not super dependent on JUCE, because I know not everybody wants to use JUCE or can use JUCE. And I think JUCE is awesome. I would use JUCE for everything. But I also didn't want to make the book super dependent on JUCE. And it's just more interesting to learn something like a filter. How is a filter implemented? Rather than just instantiating a JUCE class, just write the code yourself and see if it makes any sense.
Absolutely. Great. So I think that is all of the questions. So I'll bring us back to here we have a question from Bruno. Imagining a scenario where in the future I release a synth of my own, how careful do I need to be when it comes to using lines of code or methods of ways from your book or even other books? Great question, Bruno.
That is a great question. So, like I said, I did not write the synth myself. I took it and changed the code. It's like the code's completely different now. But I could only do this because the original synth was licensed as MIT licensed. So it's open source MIT licensed. And the source code from the book is also MIT licensed. And basically that means you can do with it whatever you want. If it breaks something, you can't sue us, and it would be nice if we get credit. But to be honest, for educational materials like this, you can just use the code. The whole point is to teach you how to do stuff and to give you tools so you can build your own products and your own things. So it would be kind of silly if we would say, oh, you need to buy a license for the code or something. I mean, there are books that do that. Numerical recipes in C++, or in C, that's a book that's well known for showing you the code, but you actually have to license the code if you want to use it for anything. But audio programming books, I've never heard of anyone being difficult about the code. So by all means, go ahead and use everything you need.
Fantastic. Looks like that's all the questions. Once again, thank you, Matthijs. Very appreciative of this collaboration that we have together. Thank you for this is a great body of work that would have taken many months to write. So I hope that anybody who's looking at this book really understands the depth of work that's needed to actually put something like this together. So thank you very much for sharing this with the world.
Well, you're welcome. Thanks for having me.